Good evening to everybody. I welcome all the participants for the 7th day of the 2 weeks International Virtual Professional Development Program, Data Science, a Revelation of the Modern Digital Era. So today, the title of the talk is Learning Process of Neural Networks, going to be presented by Dr. R. Ramkumar. Sir, I request Mr. Kumar to give a brief introduction about the chief guest today. Please, sir.
Thank you, sir. Am I audible?
Yes, sir. Audible, sir.
Yeah, thank you. Mr. Ramkumar, Dr. S. Ramkumar is currently working as an associate professor at Christ University, Bangalore. He received his MCA degree in Karunya University, MPhil from Kerpagam University. He had totally 11 years of excellence in teaching and 9 years in research. He had worked as assistant professor in PG Department of Computer Science at Subramania College of Arts and Science, Payani, VSB Engineering College, Karur, and associate professor in Kalasalingam Academy of Research and Education. He obtained his doctorate degree in computer science in Kerpagam University, Coimbatore, Tamil Nadu. He had published several papers in referred journals and conferences. His field of interest is biosignal processing, AI, human-computer interface, brain-computer interface, and machine vision. He is an editorial board member and reviewer of the several SCIE, and Scopus Index journals in India and across the globe. He had several articles in SCIE and Scopus Index journals. He had conducted many conferences, FDP, training program, seminars, and guest lectures for the faculty and students. He had acted as a chairperson and keynote speaker in several international conferences, and he had given hands-on training on MATLAB for many students and research scholars in national seminars. And also, he has given away many training programs for school teachers and students to update their knowledge in the latest technologies. He had received gold, silver, and bronze medals in national and international exhibitions for his research products on machine vision and human-computer interface. He had filed 2 patents. He had got funded projects in funding agencies like DST, CSER. He is the author of the textbook Java for Beginners, Magic Book for QA and Reasoning. And with this small introduction, may I now invite Dr. Ramkumar to take over the session. Please, sir.
Okay. So now I'm going to the presentation. Already 10 minutes is over. Okay, I hope you can see my screen. Yes. Dear participants, can you able to see my screen?
Yes, sir.
Okay. Okay, so in the today session, I'm going to give you what are the different types of learning methods that are available in the neural network. Before going to that learning algorithms and then learning methods, we need to know what is meant by neuron and what are the different types of layers which is present in the neural networks and what are the different types of architectures in which the neural networks have, and also what are the different techniques it used to learn the patterns from the given input, as well as how it is going to compare the input with the output, and it is going to produce the output for us. And I'm going to give you one little bit hands-on training with some small neural network program. If you have the MATLAB in your system, then you can able to work it out finally. Okay. So that's all. This is the roadmap. Today I'm going to cover, because my time is on only 1.5 hours. Already 10 minutes is over. So I need to complete this. So I'm going to move to the first slide. So in the today's session, we are going to learn what is meant by neuron first. Because if you try to learn the neural networks, first of all, you need to know what is meant by neuron. All are telling different answers, but I have analyzed the answers from my past research from 10 to 12 years. I am doing the research in the neurons and its activity by implementing several techniques. And also finally I'm going to show you the one demo video whatever I created from past 5 years back. The demo video I will show to you, don't worry. Okay. So come to the point. Neuron, in the neuron Greek word, a neuron means called as a nerve cell. It is the fundamental unit of the brain. Why we are calling this as a fundamental unit of brain means the neuron is nerve cell is specially made with the help of.
I would like to call upon Dr. R. Maheshwari, Associate Professor, School of Management. She has produced 2 doctorates during this year.
Can I start my presentation?
Associate.
Can I start the presentation? Okay, so neuron is the fundamental unit of the brain. Why we are calling this neuron is a fundamental part of the brain means all the nerve cell is made up of neurons. If you see the neuron, it is very, very small. So that I mentioned here as it is one of a tiny cells, and we are going to call this as one of a specialized cell. Why we are calling this specialized cell means it is going to take over the information from source to destination, but its level is on very, very small. But even though it is going to act as a main part in the body to carrying the signal from the source point to the destination point. If anybody asks you the question, what is meant by neuron, you need to give the answer as a. So neuron is a biochemical and electrical signal processing unit. Okay, so that's all. Yeah, neuron is a biochemical and electrical signal processing unit. Leave it the complex. I will tell you why. Yeah, I gave this definition as a complex. Yeah, neuron is a biochemical and electrical signal processing unit, which means it is going to process the electrical signal arise in the body. Okay, and it is going, another neuron is going to receive the signals, and all the neurons are start to fire. Then immediately it is going to combine the signals, and then it is going to give this information to the another neurons. Then the filamentary path inputs are present in the neuron. We are going to call that as a dendrites. Okay, so if anybody asks you the what is meant by neuron, you need to give the answer as a neuron is a biochemical and electrical signal processing unit which receives the electrical signals and combine the signals, and it is going to pass the information to the other neurons. Okay, so why I am telling this complex means it is a n number of neurons are present in the nerve cells. So it is very complex to find out which neuron is going to take your signal from your source to destination. That's why we are mentioning I'm mentioning this neuron is one of a complex neural network. Okay, so if anybody asks you the question, same again. If anybody asks you what is meant by neuron, you need to give the answer as yeah, neuron is a complex biochemical and electrical signal processing unit which receives the signals and combine the signals, and it is going to give the information to the another neuron. Okay, so if you take a neuron, it consists of 3 parts. Okay, what are the 3 parts? Dendrites, soma, and then axon. Okay, this is the three important components which is present in the neuron. Okay, so there are several components are present in the neuron structure, but we are going to focus only these three. Why we are focusing these three means this is a very important. All other members which is present in the neurons are present inside this. That's why we are going to consider only the dendrites, soma, and then axon. Okay, dear participants, do you have any doubt in the components of neuron? I hope that you all know what is meant by neuron and what are the components which are present in the neuron. Anybody have any doubt in this? Can I move to the next slide? Anybody have any doubt in this? See, this is the structure. This is the structure of the biological and neuron. If you see this, it consists of dendrites, soma, and then axon. I will discuss what is the work of this dendrites, soma, and then axon in the next upcoming slides. Okay. So if you see this diagram, the incoming axon from other neuron is there, which means one neuron is going to connect with the another neuron with the help of that incoming axon from the other neurons. Okay, so this is the structure of the neuron. That's why I mentioned in the first slide as it is a dendritic tree-like structure. If you see this, it looks like a tree structure. That's why they mentioned as it's a dendritic tree structure. Okay, see the next one. If you see the next slide, this is the microscopic view of the individual neuron. So in the previous diagram implements the structure of the neuron. Here, if you see this slide, it contains a microscopic view of individual neuron. Okay, so if you take this diagram, you can able to see the same thing. Dendrites, soma. See the diagram here last. It's contain dendrites and then soma, this pyramidal-like structure, and then axon is present. Here synapse is present. What is the use of this synapse? Means one neuron and then another axon is going to connect with the help of this synapse. I'm going to explain you what is the work of this synapse. So this is the microscopical view of individual neuron. Okay. Okay. Now what is the use of this dendrites? Okay. Now I am going to compare this with the artificial neural network in the upcoming slides. Okay, so dendrites is a tree-like structure which is going to get all the input from the environment, which means all inputs, whatever it is going to receive, all the inputs is going to receive with the help of this dendrites. Okay, so if you take a neural network, most of the inputs are going to take place in the form of dendrites. Okay, so the dendrites of a neuron are cellular extension with many branches. If you see the previous slide, the dendritic trees consist of several branches. So if you see the structure, it looks like a tree. That's why they named this dendrites as a dendritic tree. Okay, so from this branch, several branch, the each and every neuron which is present in the body are the, now we are discussing the biological neuron. Okay, so it is going to receive the input from any one part of this dendrite. So mostly for the human brain, 99.9% of input is going to occur through this dendritic tree. Okay, so now the dendrites receive a signal from the other neurons. Okay, now what is the main theme behind the dendrites? Means the dendrites help to get the input from the user. That's it. Okay, so here we are going to call this as an artificial neural network. This dendrites is going to act as an input layer. Okay, at the time I'm going to compare it again. At the time you will know. Here whatever which is present in the network and the biological neuron, this dendrites is equal to input layer in the artificial neural networks. Okay, now all the inputs are received with the help of dendritic tree. Now it is going to transfer to the soma, because dendritic trees are connected with the main body of the neuron called soma. If you see the soma, it is a pyramidal like structure. You can able to see here, see that pyramidal structure is there. It is mentioned in the red color in this diagram. Okay. So if you take a soma, it is going to collect all the inputs, whatever given by the dendrites. Now it is going to sum all the incoming signal, whatever received by the dendritic tree. Now this soma is equal to hidden layer in the artificial neural network, because the biological neuron, artificial neural network is going to imitate the same thing, whatever which is present in the biological neuron. That's why I'm comparing again and again. The input layer is equal to dendrites, soma is equal to the hidden layer. Okay. So if you see the soma structure, it's a pyramidal or some cylindrical shape, depends upon the microscopic view. What is the work of this soma means? It is going to sum all the input signal, whatever received by the dendrites, which means the input layer. Here now we completed the input layer and then hidden layer with the, in the artificial neural network. At the same time, we are going to compare the biological neuron. Dendrites is receiving the input, soma is going to sum all the input signal, whatever received from the neurons. Okay. So now what is the work of this soma? Whenever the sufficient input is received, which means whenever the threshold is reached, automatically the neurons start fire, which means the neuron start its own work. Okay. So whenever the sufficient input is received, the neuron starts to fire. Okay. So what is meant by fire? Neuron fire means whenever the soma sums the input signals, then automatically impulse is going to take place. Okay. So this, what is meant by impulse means a force that starts a motion. Due to motion, some force is going to take place, that you are going to call as an impulse. Now, whenever the neuron starts fire, then immediately impulse is going to pass, which means now neurons start to pass from the long fiber axis called axon. Okay. The third component of the neural network, biological neuron, is an axon. Okay, now your input is processed. 1 minute. Sorry for the interruption on important call. Okay. So now, if you see the soma, after receiving all the inputs from the dendrites, whenever the sufficient input is reached, the neuron start to fire, then immediately the impulse start to move towards the axon. If you see the axon is one of the long fiber, okay, which is indicated in the figure. See here, the blue color indicates that the following axon. Okay. So now the connection point between a neurons and another neuron dendrites is called as an axon. Okay. So now the input received from the dendrites is combined and summed with the help of soma. Now it passed to the axon. Now axon is going to connect with the another neurons. Okay, the another neuron also contain this same dendrites, soma, and then axon. So likewise, the information is going to transmit from source to destination in the same order. Okay, now already I told you in the diagram. See here, the synapse is present here. This synapse, what is the work of the synapse means? See here, the connecting point between neurons axon and another neuron dendrite tree structure we are going to call as synapse. Now your one neuron axon is present here and another neuron's dendritic tree is present. This neuron axon and then another neuron's dendritic tree are going to connect and transmit the signal from one to another with the help of the synapse. Okay. So now the impulse signal are then transmitted across a synaptic gaps by means of some chemical process going to take place in between the axon and then dendritic tree. So that chemical process is going to take place means it is going to transmit the signal from one neuron to another neuron, which means axon is the one end of the neuron and dendritic tree is the another starting point of the another neuron. So one ending point and another one starting point is going to connect due to some chemical process. The electrical signal is going to transmit from the source to destination, vice versa for all the neurons. If you take a single neuron, it have a synapses of 1000 to 10,000 synapses that are connected to 10,000 neurons or 1 lakh neurons. Some zeros are missed here. Okay, so you see the next point. There are 100 billions of neurons in our brain, and each neuron has 1000 dendrites. Approximate values are this. It may be more than this. Okay. So here after anybody ask you what is meant by synapse, one neuron's axon and another neuron dendritic tree is going to connect to transmit the signal. So we are using the point you are going to call as synapse. Due to some chemical process, it is going to transmit the information from one neuron to another neuron. Likewise, now this axon is called as an output layer in the artificial neural network. So if you take a biological neuron, it consists of 3 components called as an dendrites, soma, and then axon. Okay. So likewise, if you take an artificial neural network, it consists of input layer, then hidden layer, then output layer. So these 3 works is going to imitate like a biological neuron. That's why they named this as an artificial neural network. Here participants, anybody have any doubt in this up to this? Can I move to the another slide? Next slide. Okay. So now properties of neuron. What are the characteristics in which the neurons are here? Okay. So signals are received by the processing element, and then it is going to sum the weighted inputs. I'm going to give you a real-time example for this. We are going to give the input. Now the input is going to assume with some weight. So this assuming this weight is called as an learning algorithms. With the help of the learning algorithm, it is going to assume the weight. Now the weighted incoming signals, your weight is going to add with the incoming signals, and whenever the sufficient input is reached, immediately the neuron is start to fire. Okay, now the output produced from one neuron may be transmitted to the another neuron. So the how this weight is going to change means according to the experience learned by the learning algorithms, automatically the weights which is present in the input is going to added and modified automatically. Okay, so if you take both artificial neural network and then biological neural network, automatically these 3 components which is present in this network is going to convert your input signal to an output signal with one. It is going to have the fault tolerance also. What's my fault tolerance? If you give the error rate also, it is going to manage, and then it can able to give the output maximum correctly. Now I'm going to display some videos related to the nervous system. Okay, you see the human brain.
வீடியோ முடிய போகுது சார். Sir, is the audio available, sir, with the video?
If see now it is audible to you all.
No, sir.
Wait.
Yeah, now it's audible, sir.
Okay.
Which also continue on the spinal cord. The outermost layer is called dura mater, which is the touch and fibrous membrane. The middle layer is the arachnoid layer, which is thin, delicate, and gives a web-like cushion, while the innermost layer is highly vascular, richly supplied with the blood, and is called pia mater. Inflammation of the meninges causes the disorder called meningitis. The space between these membranes is filled with the cerebrospinal fluid, CSF. It acts like a cushion to protect.
So our neurons
shocks.
Content is over here.
Both from
See here, our part is here.
of one carrier or cytosol. Dendrites are branched cytoplasmic projections of the cell body. They are for receiving impulses from the axon of another neuron. Dendrites of one axon of the other neuron are separated by an extremely narrow space called the synaptic cleft. Through this synaptic cleft, nerve impulses are transmitted. The axon, also called the nerve fiber, is a long process of a neuron cell body. The axon is specialized to carry messages. An axon of one neuron may have enough branches to bounce. Axons are covered by a protective layer of a white insulating sheath called myelin sheath. The myelin sheath shows gaps throughout the length, which are called nodes of Ranvier. The end portion axons have swollen bulbs called axon terminals that stores certain chemicals called neurotransmitters. There are three different types of neurons. The first one is sensory neurons, which carry impulses from the sense organs to the central nervous system. The second type of neuron is motor neuron, which carries impulses from the CNS to muscles or glands of our body. And the third type of neuron is interneuron, which connect various neurons within the brain and spinal cord. It carries information between the motor and sensory neurons.
Okay.
Did you know that the brain is the most complex organ in the human body? Let us learn more.
So now I'm going to discuss the next one, artificial neural network. So from the name itself, we can able to know that artificial means imitation of the real thing, but it is not look like a real one. Okay. So neural is nothing but an adjective form for the neuron. Network means already you are familiar with the network, which means you are going to connect two different parts, which means a source and then destination. We are going to make communication in between this by sharing any type of information. We are going to call that as a network. So if you see the word combined together as an artificial neural network, it's going to imitate like a original neuron, but it's not look like a original biological neuron. Okay. See the next point, the artificial neuron represents the characteristics of the biological neuron, but we can't tell that it is equal to the biological neuron. But anyway, through the computational intelligence, we are going to make this artificial neuron to think, to behave like a biological neuron. Okay, so this, if you take a neural network functions, it's going to behave like a biological neuron. Already I compare this one with you, the artificial neural network, and then if you take a biological neural network, the biological neural network, the dendrites is equal to the input layer, and then soma is equal to the hidden layer, and then axon is equal to the output layer. Okay, so if you see, the function of the neural network is going to produce the output whenever, if you give any types of pattern, whenever the input pattern is going to match it with an output pattern, it is going to give you the output, which means the input is there and then on target is there. You are going to compare with this input with the target. So finally you are going to get the in output from the comparison. So an artificial neural network is an information processing system that have been developed as a generalization of the mathematical models. It's look like a human cognition. So whatever the biological neuron is going to perform, the everything it's going to perform, which means whatever activities the human brain, original biological neuron can able to perform, all the activities this artificial neuron also can able to perform. Like that only they have modeled the network. That's why I mentioned here as an, it's look like a mathematical models of the human cognitions. Example, I'm going to tell you that. You are going to tell the
slide, excuse me, sir. Slide is not moving, sir.
Slide moving. Same here.
No, sir.
Artificial neural network slide is there no here?
Human brain and nervous system, that slide is visible, sir. 10th slide. Slides are static, sir. It is not moving.
One minute. Now it is visible to you all. ANN parameter. Dear participants.
The slide is 11th slide, sir.
11th slide. For me is showing 12th slide. Now. See now.
No, sir. I think for participant. Oh, participant also not able to visible the next slide, sir. It is standing in 11th.
Oh, wait, some issues. Now, can you able to see the 12th slide?
Yes, sir. Now it is visible.
Okay. So now, how can you tell that it is some artificial neural network? So which means it consists of some parameters, because whatever parameters we discussed in the biological neuron, all are here. We are mentioning with some of the different names here. That's it. Okay. So ANN depends upon the following 3 parameters. What are they? We are going to discuss now. the interconnection pattern between different layers of neuron. Sometimes you can able to use a single layer, or sometimes you can able to use a multi-layer, which means the input layers and then output layers, in between that one hidden layer is present, or more than one hidden layer is sometimes present. So depends upon the interconnection pattern, the network, the patterns, the interconnection pattern between the different layers of the neuron will vary. Then next one is the learning algorithm. Whatever learning algorithm you are going to use, according to that, it is going to update the weights in between this interconnection. And third parameter is called as an activation function. Whatever you are going to implement for your neural network, this also going to vary, depends upon the network and then activation function you are going to implement in the neural network. So if it is an artificial neural network, it depends upon the three parameters. First one is interconnection pattern. Second one is on learning algorithm you are going to use to process the learning. And third one is called as an activation function, whatever you are going to apply. So what all are the learning algorithms and what all are the activation functions? Yes.
Bye, sir.
Somebody called me. Any doubt in this slide? Any doubt in this slide? Somebody asked some questions. Can I proceed?
No, sir, you can proceed.
You can proceed, sir. You can proceed. Somebody's talking.
Okay. So now architecture. So already you are familiar with this architecture, word architecture. Architecture is nothing but the interconnection and then arrangements of the layers in the technology. You are going to call that as an architecture. See the first point, the arrangements of the neurons into layers and the connection patterns within and between the layers, you are going to call this as a network architecture. So depends upon the arrangements of the neurons and its layer, we are going to give some different names for this architecture. So what are the different types of architectures are there in the neural network? Means it is a single layer and then multi-layer. This is the two types of architectures we are going to discuss in the next upcoming slides. If you see the architecture of the general neural network, it consists of three layers called as an input layer, and another one is called as an output layer, and then hidden layer. So input layer and then input layer to the hidden layer and hidden layer to the output layer. This is the general procedure till now we are following in the neural network. So input layer, what is the use of the input layer? Means input layer is going to receive the input. There is no calculation in the input layer. Only it is going to receive the input. So now I am going to match this input layer with the dendrites. Okay. So now what is the work of the dendrites in the biological neuron? Means it is going to collect the input signal from the various part of the body. Likewise, the input layer in the artificial neural network is going to collect the information. Okay. Now the second one is called as an hidden layer. The hidden layer is equal to soma. In the soma, all the input received from the dendrites is going to sum by the soma, and whenever the sufficient input is reached, then automatically the neurons start to fire. Likewise, the hidden layer is going to perform all the calculations. At the time of performing this calculation, your input layer is going to add with some weight. You are going to call as an WI. This weight is going to add to your input according to your learning algorithm and the learning methodology you are going to implement in the neural network. So now whenever the bias is going to add in the hidden layer, so now whenever the threshold is reached, now neuron start to give the output with the help of the output layer. So this is the general structure of the neural networks. Okay. It contains input layer, output layer, and the hidden layer. Okay, now I'm going to display some video for you regarding this.
Last summer, my family and I.
Can you able to see the video? You all?
No, sir.
Okay, wait.
No, sir. It is taking a few seconds to load, sir. I think network maybe.
Or can I directly come to the YouTube and then can I play this video to you all?
Okay, sir, no issues.
Right. Can you able to see the YouTube video now for you?
Yes, sir, it's visible.
We did not have any trouble in translation of Russian boards into English. This is just one of the several applications of neural networks. Neural networks form the base of deep learning, a subfield of machine learning where the algorithms are inspired by the structure of the human brain. Neural networks take in data, train themselves to recognize the patterns in this data, and then predict the outputs for a new set of similar data. Let's understand how this is done. Let's construct a neural network that differentiates between a square, circle, and triangle. Neural networks are made up of layers of neurons. These neurons are the core processing units of the network. First, we have the input layer, which receives the input. The output layer predicts our final output. In between exist the hidden layers which perform most of the computations required by our network. Here's an image of a circle. This image is composed of 28 by 28 pixels, which make up for 784 pixels. Each pixel is fed as input to each neuron of the first layer. Neurons of one layer are connected to neurons of the next layer through channels. Each of these channels is assigned a numerical value known as weight. The inputs are multiplied to the corresponding weights, and their sum is sent as input to the neurons in the hidden layer. Each of these neurons is associated with a numerical value called the bias, which is then added to the input sum. This value is then passed through a threshold function called the activation function. The result of the activation function determines if the particular neuron will get activated or not. An activated neuron transmits data to the neurons of the next layer over the channels. In this manner, the data is propagated through the network. This is called forward propagation. In the output layer, the neuron with the highest value fires and determines the output. The values are basically a probability. For example, here, our neuron associated with square has the highest probability. Hence, that's the output predicted by the neural network. Of course, just by a look at it, we know our neural network has made a wrong prediction. But how does the network figure this out? Note that our network is yet to be trained. During this training process, along with the input, our network also has the output fed to it. The predicted output is compared against the actual output to realize the error in prediction. The magnitude of the error indicates how wrong we are, and the sign suggests if our predicted values are higher or lower than expected. The arrows here give an indication of the direction and magnitude of change to reduce the error. This information is then transferred backward through our network. This is known as backpropagation. Now, based on this information, the weights are adjusted. This cycle of forward propagation and backpropagation is iteratively performed with multiple inputs. This process continues until our weights are assigned such that the network can predict the shapes correctly in most of the cases. This brings our training process to an end. You might wonder how long this training process takes. Honestly, neural networks may take hours or even months to train, but time is a reasonable trade-off when compared to its scope. Let us look at some of the prime applications of neural networks. Facial recognition. Cameras on smartphones these days can estimate the age of the person based on their facial features. This is neural networks at play. First, differentiating the face from the background, and then correlating the lines and spots on your face to a possible age. Forecasting. Neural networks are trained to understand the patterns and detect the possibility of rainfall or a rise in stock prices with high accuracy. Music composition. Neural networks can even learn patterns in music and train itself enough to compose a fresh tune. So, the following statements does not hold true. A, activation functions are B, error is calculated at each layer of the neural network. C, both forward and back propagation take place during the training process of a neural network. D, most of the data processing is carried out in the hidden layers. Leave your answers in the comments section below. 3 of you stand a chance to win Amazon vouchers. So don't miss it. With deep learning and neural networks, we are still taking baby steps. The growth have invested in developing products such as libraries, predictive models, and intuitive GPUs that support the implementation of neural networks.
So I hope that you all are know how many layers are there and how the computation is going to take place in the neural network. Input layer is going to receive the input, and then hidden layer is going to perform the computation, and then output layer is going to give you the output. So this is the general structure of the artificial neural network. Okay. So if you take another way, we are going to discuss the feed for neural network. The neural networks are classified into 2 types. Okay. So one is called as a feed forward neural network, and another one is called as a feedback neural network. Okay. So now what is the difference between the feed forward and then feedback neural network means? We are going to call this feed forward neural network is a static neural network. Why we are calling this network as a static neural network means, if from the name itself we can able to know that all the information is going to transfer in the form of forward direction alone. There is no backlink, which means a feedback connection, which is present in this network. That's why we are going to call this network as a static neural network. Okay? Which means we are going to give the input here. Input is going to process in the hidden layer, and hidden layer to output layer directly. There is no feedback connection in this network. So such type of network we are going to call as a feed forward neural network. Okay. So which means this neural network, this feed forward neural network consists of 3 layers: input layer, hidden layer, and then output layer. From hidden input layer to hidden layer and hidden layer to output layer, there is no feedback here. So they are mentioning this name as a feed forward neural network. It is said to be a static network. The reason is there is no feedback connection here. That's why they named here as a static neural network. Okay. So feed forward network computation units are interconnected in the feed forwarded way. The neural networks are often classified as a single layer or multi-layer. Okay, I am going to display some video for you regarding this feed forward neural networks.
If it's your dream to work at a bank company, all you need is to register for this free masterclass on how to become a bank engineer. Let's get it.
See the working principle of the feed forward neural networks. See, the yellow color light blinks that the information is going to transmit in the forward direction alone from input layer. The central one is called as a hidden layer, and hidden layer to the output layer. Okay. So there is no feedback network. So they named this network as a feed forward neural network. See here, input layer giving the input to the hidden layer. Hidden layer is going to make a calculation, and hidden layer is going to give the input to the output layer. It looks like a 1, 2, 3, 4. There is no 4, 3, 2, 1. So they named this network as a feed forward neural network. So till the end of this video, you can able to see this same information from input to output. See here, now jump this takes place there. See now the iteration is on 999. Your approach is on 200. Last iteration is start to calculate the output. So likewise, the number of approaches you are going to fix in the at the time of writing the code. So up to this, your neural network is going to execute again and again. If you fix the approach sizes on limiters on 100, it means it is going to perform 100 iteration. 1000 means it is going to perform 1000 iteration. Here 2000 out of 2000 iteration is performed. Finally, you are going to get the output. So this type of network movement, you are going to call this as a feed forward neural network. Now, see here, if you take the feed forward neural network, I told you that if you take a feed for neural network, it consists of single layer as well as a multi-layer. If it is a single layer, what is a single layer connection means?
Think of a familiar face, maybe that of a classmate, family member, or even a famous celebrity, and ask yourself how you recognize it. This question, known as the facial recognition problem.
If you take a single layer, there is only one input neuron, and then directly the input neuron connected with the output layer. There is no hidden layer which is present in this layer. Such type of network you are going to call as a single layer neural network. If you see the diagram, you are going to give the input values here, and then directly you are going to get the output value. All the weight as well as the bias is going to add here itself, and then finally you are going to get the output. If one input layer and then one output layer is present, you are going to call this layer as a single layer neural network. Okay. So see, the next one is called as a multi-layer neural network. So from the name itself, we can able to know that in between a input layer to the output layer, several hidden layers are present. We are going to call this several hidden layers as a cascading layers. What's mean by cascading means joining of two more than one layer. You are going to call that as a cascading layer. So in between the input layer to the output layer, there are several number of hidden layers are present. All the hidden layers are in the cascading in nature, so that we are going to receive the output. We are going to give the input with the help of input layer, and there are several number of hidden layers is present. Which means several numbers means more than one. We are going to call as on several numbers. So if there is in your network architecture, if the layers in between the input layers and then output layer, if it is contain n number of hidden layers, then automatically your network you are going to call as a multi-layer network. So the output, the general format is same. The output of the one layer is going to give us some input to the another layer. Example, input you are going to give to the hidden layer is going to process, and the hidden layer is going to give the output. That same output is going to act as an input for the output layer. Now output layer is going to give you the output from this input. Okay. See the diagram, you can able to know input layer and then output layer, in between the hidden layer is present. Okay. If the number of hidden layer is increased, we are going to call this as a multi-layer feed forward neural network. If your information is going to transmit in the forward direction, if it is a feedback, then you are going to call this as a multi-layer feedback neural network. We are going to see in the next slide. Okay. See the feedback neural network. The feedback architecture, the output signals are feedback to the input neurons. If you see the diagram, you can able to know the output. Sometimes you can able to take the output from the output layer, and again you are going to give that output as an input for further. Then you are going to call this as a feedback neural network. Sometimes you can able to take the loop from the hidden layer to output layer or output layer to the input layer directly, depends upon the network you are going to use. Okay. So if your network with one feedback connection, then automatically you are going to call this as a recurrent neural network. So what is the main use of this feedback neural network is? When compared to the feed forward neural network, it is called as a dynamic neural network. The reason is it is going to generate the output. If any mean square error is there, in this network trying to minimize the error to 0. That's why its impact was very high in the research field. So most of the researchers are going to select the feedback neural network than that of the static neural network, called as a feed forward neural network. If you see the diagram, see the video, then you can able to know how this feedback neural network is going to work for us. Okay, wait, I'm going to share the screen now. See here, the Y1 is called as an output here. X1, X2, X3 is said to be an input. H11, H21, H12, H22, and H13, H23, H14, and then H24. All are said to be an hidden layers. I told you that multi-layer feedback neural network. It contains more than one hidden layers here. H11 to H14 is on one hidden layer set, and H21 to H24 is on another layer. See the H31 is there, H32 is also there. So it contains 3 hidden layers, and then we are going to calculate the output. So now output is again going to give us an input to your input layer. If the network is going to learn up to the minimizing the 0% error, the network is going to start to learn. So this type of network we are going to call as a feedback neural network. So this is the mathematical calculation of the artificial neuron as well as the biological neuron. See here, X1, X2 up to Xn, you are going to call this as an input. So how many inputs you are going to give now? According to that, automatically the weight is going to add. So here W1, W2, W up to N indicates that weight. Okay. So here the input X1 to Xn indicates the input, and then weights W1 to Wn indicates the weight. Now this input and then weight is going to combine together. Okay, you can able to see that net equal to bias. Now bias is going to add with this. That's why net equal to B plus bias plus X1 W1. Now we are going to multiply with input with your weight here, and then you are going to plus weight second input with an second weight. Likewise, it is going on up to Xn with then Wn. All the things are going to add, and then it is going to give you the f of net. Okay. So now, which means f is nothing but an activation function. By applying the activation function, then automatically the neuron is going to give us an output here. Okay. See the video here.
Did you download Grammarly?
Neural networks are algorithms that are based on the way the brain works. They can build predictive models by learning the patterns in historical data. Neural networks are made up of small, interconnected processing elements. These elements are called nodes. Each node processes a small part of the task. The most common type of neural network is called a multilayer perceptron. In a multilayer perceptron, the nodes are organized in layers. The first layer is called the input layer. The outermost layer is termed the output layer. Between these two come one or more layers. These are called hidden layers. The input layer receives the values of the independent variables as input. The nodes of the hidden layer take their inputs from the input layer, process it, and pass it on to the nodes of the output layer. This is what happens within a node. A node receives information from multiple nodes of the previous layer. These are multiplied by unique weights and added together with a small value called a bias. This total is processed by a function called the activation function and leaves the node as output. This process proceeds till information reaches the output layer and leaves it as a prediction for the dependent variable. The network then compares the prediction with the actual value of the dependent variable. If these do not match, it adjusts all the weights in the network and repeats the process. These iterations get repeated till the neural network is able to produce accurate predictions for most of the observations. Once this is achieved, we are left with a neural network model that can be applied to a new set of data to provide predictions. Thank you for watching this presentation. To learn more about neural networks, please continue with the rest of the course.
So now I am going to compare the artificial neural network with the biological neural network. So if you take a artificial neural network, sequential processing alone possible in the artificial neural network, which means one by one only we can able to process all the activities. But if it is a biological neuron, parallel processing is possible. At the same time, we can able to see a color. At the same time, we can able to see the world, the real-time environment, real-time objects with our eyes. But if you take artificial intelligence, it is going to process the form in the form of sequential order. But parallelism is possible in the biological neuron. Anyway, compared to the artificial neural network, biological neuron is high because it is a software model of the biological neuron. So see the next one. But if you take an artificial neural network, it is high faster than that of the biological neuron. See that high processing speed is possible in the artificial neural network, but only the low processing speed is possible in the biological neuron. Okay. So next one is artificial systems are usually slow to learn, but biological systems have a property to learn very easily, because if you assume that it is a newborn child, the newborn child, you are going to tell, the mother is going to tell the newborn child, see son, this is the elephant. If you see the elephant, did you see the elephant? If you ask to the child, the child is going to tell that I have not seen the elephant. But so mother is going to give the explanation about the elephant. See child, it is one of the biggest mammal, biggest animal in the world, and then it is look like a black or gray color. It walks with 4 legs. It have one tail, and then trunk, and then tusk, 2 ears, etc. If you give the information like this, then child is going to ask that yes, 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 okay, okay. And then after 10 to 15 days, again the same mother is going to ask the children whether on the day I told you, what are the attributes are available for the elephant. the child is going to stand simply. At the same time, once the elephant is going to crash in the real time, at the time you are going to show this, show the child that, see child, this is the elephant. The next time, after 1 month or after 1 year, the same elephant is going to come in front of the child. Then automatically the child is going to tell that, yeah, see the elephant, like that. So which means this is the importance of the biological neuron. So for learning, the artificial neural network is going to take more time. But if you take a biological neuron, it is going to learn within a second. Example, one face, if you see it in the at any time, you can able to identify the same person again very easily. This is the expertise of the biological neuron compared to that of the artificial neuron. Okay. So the next third one is called as an artificial system focus on learning a single task. You can able to learn at the only one task at a time. But if it is a biological neuron, its capabilities to learn more than one task at a time. So now we comes to the last part of our presentation. It's called as on learning process. So what is meant by learning? The answer is, you are going to experience that you are going to learn. So through the experience only, we all start to learn. Likewise, the network also going to learn with the help of this experience. Okay. So here this experience indicates that parameters is going to adjust automatically according to your input stimuli. Whatever input you are going to give, according to that input, the network parameters is going to add, which means the weight is going to add with your input automatically, depends upon your input value. We are going to call this process as a learning process. Okay. So when this learning is going to stop, whenever the actual output response is going to match it with the desired one, then automatically learning is going to stop. Till that, it is going to acquire the knowledge through learning. Okay. So it is a continuous process. It is going to stop whenever the actual output response is same as that of the desired one. Then automatically the network is going to stop learning. Otherwise, the network is going to learn again and again and again till the actual output is going to match with the desired one. So according to that, it is going to update the weight automatically. It depends upon the input. The weight is going to add with your input. Then activation, then the bias is going to take place. Then activation is going to apply in that input. Then automatically, finally, you are going to get the output. When we will stop this means, whenever the output response is meet the desired one, the network is going to stop the learning and it is going to give you the percentage of the data, whatever it is matched with the input, whatever you fixed with the target. Okay. Okay. So there are 3 types of learnings are available in the neural network. So many of them are telling that different types of learnings are there. But according to my point of view, the learning takes place in the neural network in the form of 4 ways. They are called as on supervised learning, unsupervised learning, then competitive learning, then reinforced learning. This is the 4 important types of learnings are there. Next, some other rules are there, called as an Hebbian learning, etc., is there. But most of the time, we are going to focus only the supervised learning and then unsupervised learning. Okay, so this is more than enough for all the research scholars, those who are doing the research. So here, according to my point of view, the learnings are classified into 4 types. One is called as an supervised learning, and another one is called as an unsupervised learning. Third one is called as an reinforced learning. Fourth one is called as an competitive learning. Okay, so what is the difference between these 4 types of learning? We are going to discuss here. Okay, so if it is a supervised learning, one input is there and one output is there, which means a target. Here output represents a target. Now, whenever if you use a neural network with the help of supervised learning, this input is going to compare with this target. So here this target you are going to call as a teacher. So the learning is going to occur in between this input to the output, which means the target. You are going to call this as a supervised learning. Okay. So whenever the error signal is going to evaluate at the time of learning with the help of supervised learning, it is good. The error signal is going to calculate again and again till the minimum error is reaching. The network is start to learning. Okay. So here learning indicates that according to your input, whatever you are going to give in the system, no, according to that, weight is going to adjust itself. The parameter is going to adjust itself. We are going to call this as a learning. Okay. So this learning is going to stop whenever the target response is compared and both the input and then target is matched. Then actually, then the response is going to stop. Okay. So if the actual responses differ from the target, the network is going to generate an error signal. So up to the final target input and then output is going to match. Up to this, the network is going to learn again and again by adjusting its weight. We are going to call this as a supervised learning. Okay. Now I'm going to display some videos related to the supervised learning here.
Machine learning is a type of AI that mimics learning and Machine learning is a type of AI that mimics learning and becomes more accurate over time without being explicitly programmed to do so. Think recommendation engines, a common machine learning application which gives you more tailored ads the longer it observes your clicking habits. The two most common approaches to machine learning training are supervised learning and unsupervised learning. Supervised machine learning requires a data scientist to train the algorithm with labeled inputs paired with desired outputs. For instance, a shape with 3 sides is labeled as a triangle. The goal is that the algorithm can eventually take in new inputs and independently predict the correct label for the data. Supervised machine learning is ideal for binary classification, multi-class classification, regression modeling, and ensembling. Unsupervised machine learning does not require a data scientist to provide labels and corresponding outputs. Instead, the algorithm sifts through unlabeled input data and identifies patterns that it will use to group data, like how many sides a shape has. It's unsupervised because there are no teachers and no right or wrong outputs. The algorithm is responsible for analyzing the underlying structure in the data. Unsupervised learning is ideal for clustering, anomaly detection, association mining, and dimensionality reduction. Supervised learning is the more common of the two machine learning techniques. It provides accurate results, but can be complex, time-consuming, and expensive to compute. Unsupervised learning is less complex and takes place in real time, but is also less accurate.
So next one is called as an unsupervised learning. It is just opposite to the supervised learning. So from the name itself, we can able to identify here there is no target. So here there is no teacher. So network is going to form a group under some criteria and then guidelines. It is going to form a group. Okay. So it is totally different from the supervised learning. How means here there is no target is present here, which means your input does not match with the target whatever you are going to set. We are going to call this type of learning network as a unsupervised learning network. See the first one. In contrast to supervised learning, unsupervised learning does not require a teacher. Here there is no target here. That's why here they mention here son does not require a teacher. Even the unsupervised training, does not require a teacher. It requires certain guidelines to form a group, which means how the input vectors of similar types are grouped in the data by using any one of the attributes or any one of the behaviors. All the data belongs to the same category is going to join together to form a group with the help of the unsupervised learning. The third one is called as a reinforced learning. Okay, so this method does not indicate how your actual output and the desired output. So it is going to yield you the true or false indication. Okay, which means 1 or 2. See that a reinforced method nowadays we are using with the help of deep Q network. Okay, so in this method the teacher does not indicate how close the actual output to the desired output, but it is going to yield you the two conditions. One is true or false. Okay. The competitive learning is another type of learning. So here n number of neurons are fired. If you take a classroom, in the classroom suppose 60 students are there, one is going to act as a leader of the following class. So he is going to take over all the activities, whatever the faculty is going to give to the students. Likewise, the competitive learning, n number of neurons are started to fire, but the one neuron is going to take response and actively take part in the event, and it is going to give you the output than that of the other neurons which is present in the network, which means 60 students are there in your class. One student is on hyperactive. So this hyperactive learning method is called as on competitive learning. It's mainly contrast with the Hebbian, because why means in the Hebbian rule, several output neurons may be active simultaneously. Okay, but in the competitive learning, only a single output neuron is active at any time. Okay, so there is a lot of difference between a competitive and then Hebbian learning. So if it is a competitive learning, 60 students are there inside your classroom. One student, the first rank student, is going to act as a leader, and then he or she is going to take over all the activities of the class. Likewise, n number of neurons are fired, but one neuron is said to be an hyperactive neuron that is going to take all the activities and responsibilities and convert that to an output. Okay, see the one video is there.
If it's your dream to work, at a man company, all you need is to register for this free masterclass on how to become a man engineer.
Hello friends, welcome to Engineering to Google. So we'll continue our discussion with the subject of neural networks, and we're discussing this video. We'll discuss about another important used for the training for the learning process neural networks, which is competitive learning. So as the name suggests, all the neurons involved in the process, they engage in a competition here. Okay, this whole process of competitive learning, this whole mechanism. So the basic learning mechanism, as we all know, it involves the neural network being provided with new input, being stimulated by the environment, supplied with new stimulus, and in order to adjust itself to the new environment, it has to undergo certain structural changes or parametric changes. So here, in the whole process, there are two ways in which the neural network can respond. That is through change in weights associated between the synaptic connections or the change in the overall structure. So in competitive learning, what happens is that we have a neural network consisting of a single layer of output neurons here. The neurons that are filled with black outside circles, they're the output layer of neurons and the input layer of neurons. For simplicity, I have taken this simple structure. And they are connected with every other neuron possible through synaptic connections. And each of these synaptic connections, they have certain weights associated with it, marked by these. And all the output neurons also, they are connected to each other, synaptic connections. Here, participate in a competition where a particular neuron with the maximum net input, okay, the maximum net input, that is the winning neuron. Okay, so it is very much similar to, a student who secures the maximum marks in the exam comes top of the class, or in a competitive exam, candidate scoring maximum marks secures the top rank, the first rank. So, or in a general sports competition, the player with the maximum points wins. So like that. So it's a winner takes all kind of a thing. So here all the output layer of neurons engage in this competition. So here in nodal representation, we can say if we pick a particular neuron out of it, the net input, the total input is the resultant of the sum of all the individual inputs that are given to that particular neuron multiplied with their synaptic weights, and that total is called as the net input or combined input or induced local field. So the neuron with the maximum net input or combined input or induced local field, that is the winning neuron, the neuron which wins the competition. And the output of that winning neuron is set to 1. Suppose here the first neuron has the maximum net input. So the output of that neuron will be set to 1. And these two neurons will be set to 0. Suppose the second neuron, second output neuron wins the competition. Then the output value of this neuron will be 1. And the top and the bottom neuron, it will be 0. Suppose the bottom neuron wins the competition. Then that will be the output of that neuron will be 1, and the first and the second neuron will be 0. So it is kind of this. So mathematically, we can represent it that the neuron for which the induced local field Vk, as I said, I've already discussed in the previous videos also, the net input
So this is the neural network code. So you can, if you have your MATLAB, you can open your MATLAB software. So this is the general syntax to declare the neural network in the MATLAB. See that a new FF indicates that it is a new feed forward neural network. P indicates that input vector and T indicates the target vector, and S1 to up to Sn-1 indicate a size. Here TFI indicates a transfer function of the layer. By default, the neural network is going to work in the, under the tan-sig for the hidden layers and pure linear function for the output layer. Okay, these are the parameters. You need to declare only the required things, not all the things. All of them are said to be on. Most of the parameters, whatever you are using inside this is said to be on optional. So the default parameters are, these are said to be on optional parameters. You need to declare only the input and then target and then number of hidden layers That's it, more than enough. Then remaining automatically it is going to assign in the MATLAB. Okay, so here TF indicates that transfer function. So for the transfer function, if for the hidden layer, it is going to apply a tan-sig function defaultly and a pure linear function for the output layer defaultly. Okay, so here BTF represents the back propagation training function. Automatically the default training algorithm, one of the most important and valuable algorithm in the neural network for training is an Levenberg-Marguerite back propagation algorithm. By default, this neural network is going to use this train LM for the for learning. Okay, then next one is called as a BLF. BLF is nothing but a learning function, back propagation learning function. By default, it's going to assign as a learn GDM function. Performance function is nothing but on default, it is an MSC. IPF is nothing but information input processing function. By default, this is a maximum minimum is already it is present. No need to change this and all. You need to change only the input, output, and then hidden layers alone in that one. Or sometimes you can able to change the back propagation training function. It may be a train LM or some other thing you can able to use. Okay, so these are the default parameters actually which is present in the neural network. See here, if you write the code like this, you are going to get the output in the neural network. If you press the F5, you are going to get the output like this. Okay, so clear all and CLC already you are familiar with this. P is equal to input and T is equal to target. So you are going to create that. You are going to create a network with the help of new feed forward neural network with P as an input, T is on target, and 5 is the hidden layer. Okay, now we are going to simulate a network for this input. You are going to execute up to 50 iterations, so that I used here the net.train param.approaches equal to 50. So it is going to maximum 50 rounds it is going to take. So in between this 50 round, whenever the target reached with the input reached with the destination target, then automatically the network is going to stop the learning process and it is going to generate the output for you. With the help of this y equal to sim, we are going to simulate the network for the input P. With 50 iteration, maximum 50 iteration, you are going to get the output like this. If anybody have this MATLAB in your system, you can able to apply. I will share this code with the faculty development coordinator. You can use this. So now we are in the artificial narrow intelligence. In 2040, we are going to move towards a artificial general intelligence. It is equal to human intelligence. In 2016, artificial super intelligence is going to evolve. It is going to behave more intelligence than the human brain and then human activities. So that's all. Now, if you have any question related to this, you can ask.
If participants have any question, please you can post your questions.
Sorry, 11 minutes late due to the starting of the function. That's why it took 5:41. I think there is no questions from the audience. Okay. First of all, I would like to say sincere thanks to the faculty development coordinator for giving this opportunity to me. To share my knowledge in the neural network with you. Thank you.
Thank you, sir. Thank you for your wonderful session. I now invite Mr. Bharat Babu, sir, to propose the vote of thanks.
Yeah. I deemed it great honor and privilege in proposing a vote of thanks on this professional development program. First and foremost, I express my sincere gratitude to management for providing opportunity to conduct this virtual PDP program, and my heartfelt thanks to our Dean of College of Science and Humanities and the SRM Institute of Science and Technology in Ramapuram, and Vice Principal Academics and Vice Principal of Admin and our head of the department. I thank this opportunity to thank our chief guest, Dr. R. Ram Kumar, Associate Professor in Department of Business Analytics and Christ University in Bangalore. Thank you once again, and thank you very much, sir, giving the wonderful explanation about process of neural networks. Thank you very much. And I would like to express my sincere gratitude to all these resource persons for the various technical session and the delegates for their enthusiastic participation in this professional development program. And thank to the head of the various department and faculty members for the valuable contribution, guidance, and encouragement in all our efforts. And my sincere thanks to all the participants from various college and our willing responses. And I thank all the distinguished invitees present here accepting our invitations. We assure the session will be more beneficial and informative to all of us. Thank you, one and all. Thank you very much.
Thank you for all the participants for joining. Thank you, Ramkumar sir, for your time. Thank you very much. We can close the session, I think so.
Thank you, sir.
Thank you, ma'am. Thank you.
Thank you, sir.
Can I leave the meeting now?
Yeah, sure,
yes,
sir.
Thank
Sure,
you, sir.
sure.